Welcome back to our mini-series on how to make worms-like destruction in Godot. In the last video, we looked at how we can generate our starting collision geometry from an image. If you haven't seen that yet, I recommend going back and taking a look. There's also a link to the whole playlist in the description down below. Today we're going to look at how we can destroy collision shapes in real time. We'll start with how our destruction works, and then look at how it's used in this project later in the video. Diving into our code, we've got a method here called rebuild collisions from geometry. This takes in two arguments, a position in world space where we're going to cause the destruction, and a radius that defines how big our destruction will be. They're being passed through as an array because my project is calling this from a background thread which only lets you send a single argument. The first thing that we do is we take our global position and figure out what the local offset will be. All of the collision polygons that we'll be updating work in local space. Next, we put together a circle shape to represent the explosion. This will be centered on the explosion position and it will be subtracted from our existing collision shape. I'm using an 8-pointed circle. The more points you have, the more circular your circle is going to be, but the more points also requires more processing time. If we have a look at my collision shapes, you'll note that it's not a proper circle, it's a bunch of straight lines between points. 8 points gives me a good enough shape while keeping things running fast. The first loop just creates our shape, evenly spacing our number of points around the edge of the circle. The second loop goes through all of our collision shapes, and then we use the clip polygons 2D method of our geometry class to cut our circle away from the existing collision polygon. This returns a polygon for each island that now exists. For example, if you've just destroyed the corner of a box, you'll have one polygon with the new shape of the box. But if you've just destroyed the middle of a bridge, you'll get two islands, one for each side of the bridge. If no islands are returned, you probably just destroyed the last piece of geometry, so we'll delete that polygon. If we got some shapes back, we'll loop through them and populate this clipped collision. If it's got fewer than 3 points, it's too small to worry about, you've just got a line, so we'll just continue, we won't do anything with it. Our clipped collision is an array of points, and in order to set our collision polygon's polygon property, we need a pull vector to array. So we just loop through each of our points and push it into a new pull vector to array. We then check if we're dealing with the first island that got returned by clip polygons 2D. If we are, we'll just update the existing polygon shape. Otherwise, if we're not the first, we must be processing a new island. We need to create a collision polygon 2D to represent this new island. We then set its points. I'm using call deferred to call the add child method on our collision holder. This means that it runs at the end of the frame, which we need to do because we can't change our collision holder while we're iterating through its children. Because I'm using call deferred to set our new collision shapes into the collision holder at the end of the frame, I also use call deferred to update our existing one. So we know that all our collisions will change at the end of the frame. As far as destroying geometry in real time, that's all there is. You create a circle representing the bit you want to carve out. You use clip polygons 2D to subtract your circle from an existing collision polygon, and then you either update or add new ones depending on whether you've just cut something in half. Now, if we look at how I'm using this collision rebuilding as part of this project, there are a couple of other bits to understand. First off, at the beginning of our ready method, I'm adding ourselves to the destructibles group. If you remember from the earlier video about the characters, the camera, and the weapons, the explosive slimes call the destroy method from our destructible group whenever they collide with something. So, the player launches a slime, it collides with the map, that will call the destroy method of everyone in our destructibles group. So let's take a look at the destroy method. We're going to ignore everything down here until we get to the visual display video. As far as destruction's concerned, all we're doing is spawning a new thread and calling our rebuild collisions from geometry from that thread. We pass through the position and radius that came from the slime when it exploded, and then we push our thread into a destruction threads array. This destruction threads array is important because we need to clean up our threads after ourselves. In the exit tree method here, which is called whenever our destructible node is removed from the scene tree, we'll loop through all of our destruction threads and wait for them to finish. If you don't do this, Godot will give you warnings that you're not cleaning up your threads. So we've got our collision generating and being modified in real time. Now all we have to do is update the display of the map so that this terrain image here is destroyed along with our collision geometry. Have a think about how you do that, and then check out the next video to see how I'm doing it.